Hey guys, my name is Ember Sunn. I go by Ember Sunn on most of my social media platforms, just in case you guys want to follow. In today's video, we're doing a collaboration with the Google Developers Club at Florida International University to provide you guys with a solution to one of LeetCode's most popular problems. Today, we will be providing a simple and efficient solution to problem number 45. Once you're done writing the code, you should definitely try to optimize it and concise it as much as you can so it appears cleaner. Let's go ahead and jump into the problem.
Given an array of non-negative integers num, you are initially positioned at the first index of the array. Okay, well, to begin, non-negative is a little bit extra. We could just say positive right here. So, given an array of positive integers num, you are initially positioned at the first index of the array, right? Each element in the array represents your maximum jump length at that position. Your goal is to reach the last index in the minimum number of jumps. You can assume that you can always reach the last index. Let's make sure we understand this statement right here. So let's look at the array in example 1. You can see that we start off at 2, and so because we're starting off at 2, we only can jump 2 times within this array. So we have 2 different possible areas that we could jump. We can jump in 3, or we can jump at 1. That says here our goal is to reach the last index of the array with the minimum number of jumps. Conveniently, we have a 3 right next to the 2, so we're going to jump to number 3. And from here, we're going to be given more options to jump. So at number 3, we can jump up to 3 different indexes. So these right here. Conveniently, number 4 is our last one, and it's within our subarray. So we're going to jump all the way up to number 4. This means that our output is going to be 2 because we have 1, 2 jumps. As you can see, it explains it here. An explanation: the minimum number of jumps to reach the last index is 2. Jump 1 step from index 0 to 1, then 3 steps to the last index. Let's give another problem so we could understand this question better, right? So here we have a different array, and we want to find the minimum amount of jumps necessary to reach the last index, right? So we're always going to start off at the first index, index 0, which is 3. This means that we only have 3 different jumps that we can do. So we would have to be starting off at 5, and then the maximum amount of jumps we could take is up to 1. So then technically this would be like our current state and then the max amount of jumps that we could do. Now if we don't process the question correctly, we're going to want to jump to the farthest integer that we can, right? But it's not convenient because if that integer is a low number, then we're not going to have as much power in our next jump. It's more convenient for us to pick the greatest number within the subarray that we have. In this case, it's going to be 5. So now 5 is going to be our current number. Now we have a new set of possibilities. We have 2 and we have 6. And from this subarray, our furthest one happens to be our biggest integer within the subarray. And so from 5, we can jump all the way up to 6. Now we only have one more integer before our array ends completely. So to get to the end, we're just going to jump one more. So now that means the outcome is going to be 3. I accidentally wrote 6. This is an edit, but I will correct myself further on in the video. Now this approach that we are taking is called the greedy approach because we are picking the largest number within the subarray. And so this is the approach that we are going to take in order to create our code. So in order for our code to run efficiently, we have to consider the following. We would need to mark what would be the end of our subarray. For example, in this case, the end of our subarray would be 1. We have to write that down. We also have to consider what would be the farthest place that we could actually reach. And of course, we also have to make sure that we are counting the amount of jumps that we are taking. And I genuinely have no idea why I wrote 6 here. It's supposed to be 3, obviously, because we took 3 jumps. First, we will need 3 different integer variables, right? The first one has to count the amount of jumps that we are taking. So we're just going to name it jumps. We are also going to need one that is going to mark the end of the subarray. We'll call it the last integer. And another that will mark the farthest place that we can reach. So we'll just call this one max integer. So what we're going to do is we're going to create a for loop that is going to iterate through our array. Now, because we don't need to jump any further after the last integer of the array, we're just going to eliminate that last integer. The next thing we have to do is check how much we can jump in the current index. And what we're going to do here is we're basically going to update our max integer if the latter is larger. Now, in the instance that we reach the end of our jump, we're going to have to create another jump. So if our index is the last integer, then we are going to jump one over. Now the last thing to do is to basically jump out of our for loop and to return the amount of jumps. Okay, let's run this. Of course I didn't. Perfect. Forgot to put the integer here. All right, perfect. It looks like our code is running. Let's submit it. So that's basically it. I hope that you guys were able to understand how to solve this. I definitely wanted to mention this approach because it's easier to digest this kind of code first. And then obviously if you can optimize it and concise the code better, you definitely should. Now for our time and space complexity, because we are iterating through the array, this makes our time O of n. And because we are not using any other data structures, our space complexity is going to be O of 1. Thank you guys so much for watching. I'll see you in the next LeetCode problem.